Good morning, Further 3-4 students. Welcome to your first ever Further video. In class, we spoke about types of data. Today, we're going to look at displaying data. Specifically, we're going to look at displaying categorical data. Now, there are many different types of charts. This table here gives you an idea of just how many there are. There are huge numbers, and we aren't going to use all of them. Specifically, we're looking at several key individuals. Clearly, bar charts and column charts are good for us. We use line charts. We are going to use histograms, line histograms, and scatters. We won't use pie charts very much, but you should all be familiar with what they are. And lastly, the one that isn't on here that we will be using is box plots. And you might notice that here, in this diagram, we can compare things with 2 or 3 different variables over time, whether we're looking for a relationship or a distribution. Depends on the type of chart we use. And the idea is we want to get quite good at thinking about, if we've got this information, what would make sense in a way to present it clearly. So, to take 2 quite crude examples, for categorical data, we typically use these 2 things. Either a bar chart. You'll have seen these before. Quite clearly, we're comparing 2 variables, one being the type of technology, the others being the number of users in millions. You don't have to copy these charts down, you have to be aware of what they are. We will do practice making these, interpreting them. Interpreting them is a huge part of this course. Lastly, or last type of chart, is a segmented bar chart. Now, a segmented bar chart is when we want to compare 3 variables. We have the season, winter, spring, summer, etc., the number of sales, and we also have the type of treat. So you can see that in summer, unsurprisingly, there is far more ice cream as a percentage of the total. Whereas Coke decreases quite a bit in winter, it stays relatively steady throughout the spring. So you can tell the amount sold in each period. And you will have to be able to create these and also create them using splitting it up by percentages. All right. Now, when you're asked to describe categorical data, sometimes you'll be asked to write a report for it. So, comment on this data would be a typical exam question. And you need to do several things. So some guidelines for writing a report, and we're talking a sentence each, doesn't have to be a huge amount of time spent on each one. Briefly summarize the context in which the data was collected, including the number of individuals involved. Now, the reason we do this is because typically the more individuals in a study or a survey, the more reliable the data is. And the way the data is collected affects the outcome. So it's useful for whoever's reading this to know how it came about and how many people were surveyed. If there's a clear modal category, remember modal is most common. So above, whoa, that didn't help. The modal category for technology used is telephone, with 8 million people using it. And it's important that when you state the modal category, you also state the number. Telephone, 8 million people. Easy enough? Include frequencies or percentages in the report. Percentages are preferred because they're very easy to compare. If I told you 8 million people use the telephone, well, that's okay, but it's not really very interesting if you know, for example, that 30 million use a television or 5 million use a television. 8 million is only useful if you have all the numbers comparing. But if I tell you that 40% of people use telephones, then that's very useful because you know exactly where that lies in comparison to all the other technology types. So percentages are preferred. And when you're answering questions, often we compare percentages. If there are lots of categories, you don't need to mention every one, just the modal one. Alright, here's an example. It is cut straight from your textbook. Please don't waste too much time copying it down. You are welcome simply to print it out. Or if you're comfortable with the concept, then leave it aside. And that is a solution to a report. Number and how they were classified. The majority, so mentions the modal. And because there aren't many, they mention the rest. Alright, this is important. A significant difference in further mathematics is considered to be anything more than 5%. So with this in mind, we're going to look at an exam question from a previous year. The following table shows data obtained by the Australian Bureau of Statistics in 2013 regarding the percentage of male and female salary earners in each age group. So, In the 15 to 24, there is 51% male learners, 49% female, etc. Question 1. In the 55 to 64 age group, 329,890 people were surveyed. Find the number of males in this survey group. What we would do is we would look at this. We would say, all right, well, in that group there, of the 300, etc., 1,000 people surveyed, 52.2% of them male. So in order to find how many males were in that group, we would do 52.2 over 100 multiplied by 329,890. And the result for this is 172,202.58. Now clearly we can't leave that as an answer because having 0.58 of a person is silly. So our answer, we would round to the nearest whole number, 172,202,203 rather, because we're going to round up, because the 0.58 rounds up. Alright, in the two-way table above, it appears no association between gender and age. Explain why, quoting appropriate percentages to support your explanation. So when it says this, you need to quote numbers. I can't stress that enough. If you're asked which class does better, you can't say class A. Or you can't even say class A because it has a higher mean. You must say class A because it has a higher mean of 60% compared to class B's mean of 45%. Whenever you compare statistics, there must be a number in there. Alright, so explain why quoting percentages. So what we look at here is look at each age group and compare the percentages in each gender. And we notice that there are more men there, more men there, more men there, more men, less men there, more men there. So even though there are differences, we remember the 5% rule. Because of none of those differences is greater than 5%, we say none are statistically significant. So none of these differences are statistically significant. The last one is, however, that is many, many age brackets, and we don't know what the percentages breakdown are for each age bracket. So each age bracket could well be less than 5%. So to answer this one, you would write out each age group and explain that for each one, there is no greater than 5% differences between the genders. You would only have to give one as an example. So you could pick the 35 to 44 range, and so there'll be no more than 5% difference. Alright. That finishes the first video. We'll do lots more on drawing graphs in class, but for now, you just need to know the basics of writing a report, how to compare percentages, and then know we talk about a lot about percentages, and these two types of charts. Alright, thank you very much. I'll see you tomorrow.